pleased to hand over to Glyn Hudson now from OpenEnergyMonitor. If you're not familiar with OpenEnergyMonitor, Glyn's going to tell you about it, but it's an incredibly well-respected open source platform for monitoring heat pump performance and other renewable energy technologies. So yeah, looking forward to Glyn's insights.
Okay, thank you, Will. Hello, my name is Glyn. Glyn Hudson. I'm one of the co-founders of OpenEnergyMonitor, and we run a website called HeatPumpMonitor.org. Can I have the next slide, please, Will? So HeatPumpMonitor.org, it's an open source project to share independently monitored heat pump data. We set it up to help support peer-to-peer learning and highlight what's possible with heat pump performance. Next slide, please, Will. So currently, as of today, we've got 383 systems on the site with live independent monitoring. And these heat pumps have been installed by many fantastic installers all over the country. Most are small independent installers, but there's also some larger companies there as well. And these heat pumps, they're all metered with independent metering equipment. It's the same grade of metering equipment that's used in the RHI and other government trials, and it's fully MID certified. And that system's been provided by us to do the monitoring. So out of those 383 systems, 280 of them have been installed for a period of over 12 months. And you can see the performance figures, speak for themselves. These are we've got some very high performing systems on there, which is fantastic to see. So overall, the SCOP, the seasonal coefficient of performance of space heating, averaged 4.1. The hot water performance averaged 3, and the overall combined was 3.8. Next slide, please, Will. So I'm just going to briefly compare the performance of the heat pumps on HeatPumpMonitor with the performance of the heat pumps from the electrification of heat data, which was the last sort of government trial on heat pump performance. It was a BEIS-funded trial from 2020 to 2021, and they installed a large number of heat pumps with monitoring, 545 systems, and the average SCOP of these systems was 2.9, which is above the MCS minimum of 2.8. But you can see from the distribution there, quite a few of them fell short of the minimum, and that minimum figure, it's a minimum. Heat pumps can do much better than this, and we should be trying to make heat pumps work better than this. But the good news is, I think from the data we've seen, it is possible to install high performing heat pumps without too much difficulty. Should just say thank you to BEIS for making the data from this project available. We've loaded it into our platform and published it on the website electrificationofheat.heatpumpmonitor.org, where you can easily browse all this fantastic data set of heat pumps, of monitoring data. Next slide, please, Will. So just comparing the performance of HeatPumpMonitor on the left with the performance of the heat pumps from the electrification heat trial on the right. The average heat pump on HeatPumpMonitor has 23% lower running costs compared to the average heat pump in the electrification heat trial. That equates to around £400 a year saving on the heating bill. So it's a substantial amount. So it's definitely worth trying to do this. And those red lines there just show the cost parity with mains gas. As you can see, not many systems from the electrification of heat were lower cost than gas. That is on a price cap tariff. If on a smart tariff, especially with heat pumps and solar, it is possible for a heat pump to achieve cost savings over mains gas with a lower performance. But obviously, the higher the performance, the easier that is, and the less susceptible the user will be to fluctuations in energy prices. Next slide, please, Will. So let's first touch on the similarities between the high-performing systems we've got on OpenEnergyMonitor and the electrification of heat systems, which are probably fairly typical of heat pump installations. The trial reported a high level of customer satisfaction. People were generally happy with the heat pumps, and there weren't any significant issues with internal temperature. We pulled the data from HeatPumpMonitor, and we could see that on the coldest day of last year, where the average temperature dropped down to 2.5 degrees over that day, the average indoor temperature from the heat pumps on HeatPumpMonitor was 19.5. So heat pumps keep people warm, and there was that's quite clear, and there was the same outcome from the electrification of heat trial. Next slide, please, Will. Another similarity between what we've seen on HeatPumpMonitor and electrification of heat data is that heat pumps can work in houses irrespective of the property age and insulation level. We pulled the data from HeatPumpMonitor to look at this in detail, and you can see the table on the left here, a range of different age of properties, and there wasn't a significant difference in the performance of the heat pumps in those properties, in the different properties. And the same on the right, we've got a table here showing different levels of insulation in houses, and again the SCOP, the SCOP performance, didn't differ considerably with different amounts of insulation. So I think once you've got loft insulation, good fit in doors and windows, putting a heat pump in should definitely be the next thing on the agenda. Next slide, please, Will. So the key difference we've seen between the systems on HeatPumpMonitor and the electrification of heat systems, which is the main differentiating factor, was poor commissioning. Yeah, Matt touched on this. Basically the electrification of heat systems, almost all of them were running much higher than necessary flow temperatures. So the golden rule with heat pumps is the lower the flow temperature, the higher the performance. That's just physics. So that's something we saw again and again when we were analysing the heat, electrification of heat data. We also saw that there was suboptimal hot water storage commissioning. The hot water was often stored at a very high store temperature with a very low hysteresis. So the heat pump, as soon as a small amount of hot water was drawn off, the heat pump would almost immediately kick in to try and reheat the tank, even though it's still piping hot. And that results in poor hot water performance. Next slide, please, Will. So let's go and have a look in detail to see what this looks like. So this is examples of two heat pumps with the data on our system. So on the left we've got a heat pump from HeatPumpMonitor, and on the right we've got one from the electrification of heat. So both of these heat pumps are exactly the same. They're both 7 kilowatts of Valent Aerotherm Plus heat pumps. They're good heat pumps, with generally have good control systems, but we can see here that the differences in how one heat pump is set up does have a considerable difference. Both of these heat pumps over this 24-hour period were running with the same outdoor temperature of 4 degrees, and they both had 21 degrees inside the house. So you can clearly see that this is the system on the left from HeatPumpMonitor. It's running at quite a low, steady flow temperature, trickling heat into the property throughout the day. In this example, it's running at 32-degree flow temperature, trickling about 2.5 kilowatts of heat into the property, where the system on the right is running quite sporadically. Every time the heat pump comes on, it works really hard to raise the flow temperature up to about 55 degrees, and then it switches off again. That's not the most efficient way to run a heat pump. Low and slow is the best way, and that results in significantly improved performance. You can see on the system on the left achieved a space heating efficiency of 4, where the one on the right from electrification of heat was only achieved a space heating efficiency of 2.6. So it resulted in the well-commissioned system on HeatPumpMonitor using 17% less electricity to deliver 35% more heat. So that's quite substantial. But the good news here is this is just control settings that caused this. So it should be relatively easy to fix if this had been picked up. And this is where monitoring can really help to visualize what's going on and see that there is an issue like that. Next slide, please, Will. So in summary, these are the main things that we've found to, well, improve or avoid poor performance of heat pumps. So in general, simple open loop heat pump systems tend to perform best. Avoid third-party controls. Best to use the inbuilt heat pump controls where possible. Avoid zoning, avoid buffer tanks, hydraulic separation, avoid glycol, avoid hybrid systems, avoid deep setbacks in the schedule. Design for the lowest flow temperature possible. The systems on HeatPumpMonitor averaged a design flow temperature of 40.5 degrees, but many of them are running lower than that. Aim to store hot water at about 45 degrees, maximum 50, with at least 5 degrees hysteresis. Next slide, please, Will. A possible solution to this problem of commissioning is heat pump optimizers. And these are not to be confused with on-off third-party controls. Heat pump optimizers integrate deeply with the heat pump and automatically adjust the heat pump to work well in a specific property. They'll automatically adjust things like the weather compensation, so they avoid the problem with incorrect weather compensation being set up during the commissioning. So these are very promising systems, but I would like to see some more real-world data to prove effectiveness. But I think these could be quite promising solutions, and also manufacturers are improving their control systems as well. Next slide, please, Will. And just to touch on the installation of the heat pumps, most of the systems on HeatPumpMonitor were designed and installed and commissioned by the same. Each individual heat pump, was installed by the same company. So what I mean by that is the same. You don't have a different company doing the design, a different company doing the installation, and maybe someone else doing the commissioning. That's definitely not the way to get a good, conducive to good heat pump performance. You want the smallest gap possible between the designer, installer, and commissioning, ideally to be the same, same small group of people doing that, so they have full ownership of the system and fully understand every aspect of the design. So avoid subcontracting. I know quite a lot of that happened during the electrification of heat trial, which was probably quite suboptimal to performance. And choose the installer very carefully. In working with good installers is key. It's definitely worth looking for evidence of further training over and above the basic 3-day heat pump courses, and over and above MCS. Look for things like heat geek training, presence on social media. If they're sharing their work and engaging technically with other installers, that's a good sign. We've also created a map on HeatPumpMonitor to show the installations over the country, and you can see the performance of every one of those systems and see who installed that system. So it's a good way to find good installers in the area. Have I got one more slide? Yeah, one more slide, please. Well, this is my last slide here. And if you are interested in digging further into the data, you can obviously go on the HeatPumpMonitor.org website. But my colleague Tristan Leo and I have also written up in detail the results from HeatPumpMonitor, and going in further details to what makes a good high performing heat pump system. Cool. Thank you.
Brilliant. Thank you very much, Glyn. That's really, really useful insights. Really key message as well about how not always, but quite often, some of the differences between low and high performance can be relatively easy to fix, things around commissioning and other control settings. So that's a really, really important message.